Here we go, page 72. So yesterday we found side lengths of triangles using trig. Today we are going to look at angle measures, and that's going to require inverse trigonometric functions. So let's talk about inverses first, and hands off the calculators till I tell you to touch buttons. What is the inverse of addition? Subtraction. What is the inverse of multiplication? What is the inverse of squaring something? Square rooting. Okay, right? We got all that? So there is an inverse to trig as well, to the trig functions, and it's not division or anything like that because the inverse of division is multiplication. So you got to keep that in mind. There's an actual true inverse for what you're doing. You'll talk a lot more about inverse functions in Algebra 2, but still want you to understand that we use, I know the word opposite has been used with you a lot, but truly it's inverse is what you should be saying. Okay. All right, so we're going to look at the inverse trigonometric functions. It says if you know sine, cosine, or tangent of an acute angle measure, you can use the inverse trigonometric functions to find the measures of the angle. Because remember, it's a function. I'll say trig functions, trig ratios. They're kind of interchangeable. So we're going to do that here. We're going to take this and we're going to solve for x, right? So I want to get, that means I want to get x by itself, right? When you solve for x, you're isolating x. So do you think I can just divide both sides by sine and get x by itself? No, because this operation here is not multiplication. We're not saying sine multiplied by x. It doesn't make sense. Sine all by itself doesn't mean anything, just like a square root sign by itself doesn't mean anything, or an addition sign or a division sign or whatever. You with me on that? So we're going to first start by rewriting this. So I'm going to write sine of x equals, leave a little bit of space, and then 2/3. We want to do the inverse. If it was multiplication, we would divide. If it was addition, we would subtract. Okay, so in order to do the opposite here of sine, that is the sine inverse. Right, so let's first, I got ahead of myself here. Should have written that over here first. So the inverse looks like this. It looks like sine to the negative 1 power. You don't ever say sine to the negative 1 power. Okay, that's what it looks like. That's not what's happening. I walked down the hall one time and I heard another geometry teacher saying sine to the negative 1 power, and I wanted to like pass out or go in there and steal her pen, but I didn't. So I don't have to worry about it anymore, but it is what it is. So you can say this a few different, I was like, oh my Lord, please no. Huh? I'm not going to answer that question. But no, they don't. But no, they don't. All right, so we can say this as, the way you say this, because you don't say sine to the negative 1 power, except to say that's what it looks like. It is, you can say sine inverse. You can say inverse sine. And then you can also say arc sine, which is really a more upper level thing, but even at the upper level, you could say it the other ways too. I mean, it is what it is. So sine inverse is what we'll say. Makes the most sense, I think, for us right now. But it's the inverse sine function and arc sine. So there's also cosine inverse, tangent inverse, or inverse cosine, inverse tangent, and arc cosine and arc tangent. But we'll go with just the inverse. Okay, we good? So what I need to do, since the opposite of sine, or the inverse of sine, is a sine inverse, I need to take the sine inverse of both sides. So once I'm here, I do the sine inverse of both sides. All right? Now, the sine inverse of the sine of x, what do you think that's going to give me? Why are we doing the inverse of sine? To get x by itself, right? So if I take the sine inverse of the sine of x, what do you think it's going to give me? X. Because think about this, the inverse. If this was 3 times x, we would divide by 3, right? So when you do the inverse, it cancels out and you're left with x, right? And same thing if this was 3 plus x, I would do the inverse and I would, then I would subtract the 3 or whatever. So the sine inverse of the sine of x, you do something and then you undo it, you're right back where you started, yes? So the sine inverse of the sine of x is just x. So x equals the sine inverse, oh, goodness gracious, the sine inverse of 2/3. Okay, everybody with me on that? That is how you undo it. There's no division because there was no multiplication. We good? All right. So now, now's when you get the calculator. So on your calculator, first of all, if you cleared the RAM like you were supposed to, or even if you didn't, what do you have to do first? Mode. So you go to your mode, put it in degree mode if it isn't. Mine is because I didn't clear mine. And then look at your calculator. Where do you think sine inverse is? Right above sine, right? So second. So you do second sine, so you get sine inverse. And then you do 2/3. And you hit enter. Bam. You get 41. So x equals 41.810. Now, what does that number right there represent? An angle. Why is it an angle? Good. Whatever you take the sine, cosine, or tangent of is always an angle, right? So the sine of x, the sine of x equals 2/3. That means that the sine of whatever this angle is has a ratio of opposite over hypotenuse as 2/3. Does that make sense? So when you do the inverse, you're finding angle measures because this represents the angle, and then we figure out what it is. So that has degrees on it. It is an angle. Everybody okay with that? Okay. So let's look at this. This is just to kind of make sure that you understand it works for all of them. If the sine of A equals x, right? The sine of A equals x, and I want the measure of angle A. To get the sine away, what do? Sine inverse, right? So I take the sine inverse of both sides. So the sine inverse of the sine of A would be what? A. So the measure of angle A equals, over here, it would be the sine inverse of x. Does that make sense? So if the cosine of A equals y, then the measure of angle A equals what? What do you think? Cosine inverse of y. If the tangent of A equals z, then the measure of angle A is equal to what? Tangent inverse of z. That makes sense to you? And those things that you're taking the inverse of are some sort of ratio. A ratio can be a fraction. It can be written as a decimal. A ratio technically can even be a whole number, because if my ratio is 4, then it's really just 4:1, but you're just representing it as 4. Okay, so, but whatever that is, it's not an angle. You don't take the inverse of an angle. That doesn't make any sense. We okay on all that? Okay. So let's think about this. Since the sine of 30 degrees equals 1/2, we already know that. We've already figured that out. Then I want to rewrite this, and I could say that then I know that the sine inverse of what equals what? What do you think goes in there? Sine inverse of 1/2 equals 30. Go ahead and do sine inverse of 1/2 on your calculator. See if you get 30 degrees. Yep, you get exactly 30. Sometimes you get whole numbers. It's like you either get a whole number or you get an insane decimal. Very little in between. All right, so let's just go ahead and just type these in. And one of the reasons I want you just to have these values here is, again, for if you're checking on your own device to see if you have it in degree mode or whatever, that you know you're getting the right thing. Also, I know that you really, really, really need to get Wabbit Emo downloaded on your tablet, because some people are having issues. They're doing it 100% right. I've done this a bazillion times, and so I was in there. It was deleted. I think I know what the fix is yet. I haven't actually been able to try it on anybody, but some people are doing it just fine, and some people are having issues. And so I need to know as soon as possible if you're one of the ones having issues, so that I can figure out if everybody's having the same issue or what, because it's not a user problem. It's a tablet thing, but then everybody should be having the same problem, and they're not. So I need to know like soon if you're having issues. All right, so go ahead and type these in, get values for me here. I don't even have my spinner up yet, so I'm just going to have y'all call these out. Tangent inverse of 0.75 is what? 870, right? Good. All right, and then again, make sure you're typing these in. Don't just have wait till we write them down. All right, and then the next one is 87.134 and 42.067 degrees. We all good? Any questions about that? All right. No, we don't have to there. That's a good question. We didn't really have an x because technically it wasn't an equation. Does that make sense? So you can, but it's not even anything. It's just that. Technically, I guess it's just that's equal to that. We want to do it that way. All right, so now we're going to solve these right. We're going to solve the triangles. If we're going to do trig, what should we write up here at the top? SOHCAHTOA. S-O-H-C-A-H-T-O-A. When you solve a triangle, that means you find everything you don't know. Okay, that's what solving the triangle means. So even though we did side lengths yesterday, we're going to do side lengths a little bit today, but not a whole ton of it. And read these directions. It says, round the answers to the nearest thousandth if they cannot be expressed as exact answers. So if they can be expressed as exact answers, then it needs to be. All right? It can't be, like yesterday we had the, we found cosine of 30 and sine of 60, and it was square root of 3 over 2, but one of them was a decimal. So it can be represented both ways, but I would need to have that one exact. If it can be exact, it needs to be exact. So make sure we're paying attention to that. All right, so since I have to solve it, I have to find both angles and the missing side. So we'll start with the angles. When you do trig, you're supposed to decide which angle you're using. Well, I have to find them both, so it doesn't really matter which one we start with, right? Which one you want to start with? Which angle? 10. No. Okay, we'll start with A. All right, so there's my angle. This is the opposite. This is the hypotenuse, and this is adjacent. So, angle A. I don't know what the hypotenuse is. Even if I had found that already, if I don't have to use it, I'm not going to use it. You always want to use what they give you, right? So, I have opposite and adjacent. Which trig ratio uses opposite and adjacent? Tangent. Okay, so it's the tangent of what? Of tangent of A equals opposite, which is 10, over the adjacent, which is 12. Okay, can you reduce the fraction? Yes, don't. Who cares? You ever reduced a fraction wrong? Yeah. If your final answer is a fraction, you need to reduce it. If it's inside of something and the calculator's about to take over, don't bother, because if you mess it up, then you're just wrong. Does that make sense to you? Whether you reduce it or not, you'll get the same answer as long as you do it correctly. But again, we want to try and eliminate as much user error as possible, and so we're all capable of weird mistakes, right? So for this one time, I'm going to make you write one extra step. You don't have to do it every time. We're not even going to do it on every example. I just want to make sure that we're all on the same page here. I'm solving for A, right? So what do I have to do to both sides? No division here. No multiplication either. It is the tangent inverse. So I'm going to take the tangent inverse of the tangent of A, and that's equal to the tangent inverse of 10 over 12, right? So I'm taking the tangent inverse of both sides. I'm okay with you skipping that step in the future, but as long as you understand what you're doing. So what this tells me here then is that the measure of angle A is equal to the tangent inverse of 10 over 12. And again, I don't need to reduce it because I'm about to type that in the calculator, okay? So now that you're here, I've gotten the measure of angle A all by itself, and now you're just going to type that into the calculator. So tangent inverse, I do second tangent, 10 divided by 12, and I get that the measure of angle A is equal to 39.806 degrees. Okay. Everybody okay with that? Any questions at all? Okay. And if you want to, go ahead and what does this reduce to? 5 over 6. Take the tangent inverse of 5/6. Didn't say it. You get the same thing, right? Because it has the same value. And so that's why it doesn't matter how big or small the triangle is. It's the same ratio, and that's why you get the same angle measure. Okay? We all good with that? All right, so now I also need angle C. I got a couple of options on how I can find angle C. What's one way? I could subtract it from 90, right? Because don't your acute angles of a right triangle have to be what? Not equal. They have to be, what's the word? No. The acute angles together have to be what? Complementary. Okay, they have to be complementary. So I can just subtract from 90. But what if I messed up on angle A? I'm done. I'm guaranteed to get the other one wrong too, right? So subtracting is fine. And if it's like a last second thing, okay, that's all I have time for, I would do that. If it's not that huge of a deal to work it out, you might want to work it out. We're going to work it out in this example regardless of how you do it. So we're going to go ahead and we're going to just solve for angle C. And then we can check ourselves to see if they actually add to give us 90. So since I'm using this angle, I have to relabel it. This is now the opposite side. The hypotenuse is still the hypotenuse. This is now adjacent. Okay? So I'm still using tangent. It's just the reciprocal, right? So the tangent of C is equal to the opposite, which is 12, over the adjacent, which is 10. Got to get C by itself. Remember, there is no multiplication. There is no division. Inverse. So if I take the tangent inverse of both sides, that means that the measure of angle C is the tangent inverse of 12 over 10. Okay. So tangent inverse of 12 divided by 10. And I get 50.194. If I add 39.806 to it, ooh, I don't get 90. Why not? Because we rounded it, right? If I'd have stored my answers, then I would have gotten exactly, but I didn't store it. But that will work. So measure of, that's where rounding error is an issue. What's the measure of angle C then when I round? 50.194. If I add my rounded answers, they do give me 90. That doesn't necessarily always happen either, depending on just what's going on in the problem. Okay, everybody good? All right. So I've got my two missing angles. I also need to find my missing side, which I will call it X so that I have something to call it. So how can I find this? Is it a 45, 45, 90 triangle? I can do Pythagorean theorem. Could I use trig? I could use the angle A that I found, and I could use 10 or 12, and I could do the trig. You would have to make sure that you had stored the angle, right? And again, you're using something that you found, so, and that would, sometimes you may have to solve something that way. So that is a way we need to think about. But if I do that, am I going to get an exact answer? No. I mean, it's possible I could get my whole number, but it's not going to give me anything else weird. So I'm pretty sure that with that 10 and 12, I'm not getting like a Pythagorean triple or anything. So I need to do Pythagorean theorem because that's the only way I'm going to get my exact answer. All right, so this is going to give me 10 squared plus 12 squared equals x squared. What's 10 squared? 100 plus 144 equals x squared. So x squared equals 244. So x equals what? Square root of 244. Is that a perfect square? No. Okay. So I do my tree. Well, that's even, right? So it could be 2 and 122. Well, that's even again. So 2 and what? 61. 61 a prime number? Yes. Okay. So then that means that x is equal to 2 square root of 61, but that's really the length of what? AC? Yeah. So the length of AC equals 2 square root of 61. Okay. Everybody okay with that? Any questions at all? Yes. Right, so on my calculator, when I found the measure of, or when I took the tangent inverse of 12 over 10 and I have 50.194, blah, 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 and I just added my rounded answer to it, I didn't get 90 because there's rounding error. Yeah, that's why you can't round in the middle of stuff and then try and use it because it's going to throw you off on your values. You store things and you use what you have as a stored value if necessary. All right. So next page. What do I need to write at the top here? SOHCAHTOA. As soon as there we go. SOHCAHTOA. Right. So it says find the unknown measures, round the same directions. Round to the nearest thousandth if they cannot be expressed as exact answers. All right, so I've got to find my angle measures again. Which one you want to start with? B? All right, we'll start with B. Okay, so there's my angle, angle B. This is my opposite. This is the hypotenuse. This is adjacent. So which trig ratio am I going to use here? Cosine, okay, because it's adjacent and hypotenuse, right? All right. Cosine of what? B. Cosine of B is equal to what over what? 12 squared root of 2 over 20. Right? We agree with that? All right. So then, what do I do to get B by itself? Inverse. So the measure of angle B is equal to the what? Cosine inverse of 12 squared root of 2 divided by 20. Okay, so go ahead and type that in your calculator. All right, anybody having issues? Remember, the calculator is only as accurate and as intelligent as the person pushing the buttons. So think about what you're good. If you got a number, then we're good. So measure of angle B equals what? 0.948 degrees. Okay? We're good. So I'm going to type that in. If you did not get that and you got an error, see if you can figure out what was this? Cosine inverse. Cosine inverse of 12 square root of 2. It's gonna think that you're taking the square root of 2 divided by 20, and that's not what's happening. Okay. If you don't close the parentheses here, then it thinks that you are taking, well, it doesn't think. What you're telling it to do is take the square root of 2 divided by 20, right? And then you're taking the cosine inverse of some ginormous number, right? That doesn't really make any sense. So I want the cosine inverse. I've got to close that and then divide it by 20. And that gives me my answer. Okay, so now I'm going to leave that in there. And we can store it. We're not going to store it as long as it's the last thing that it's showing me, because you need to know how to use the calculator to your benefit. And I don't mean as a tool to help you add and subtract, but to make your life easier and have exact things and not necessarily always have to store. Again, we could here. But I need to, what I want to do, because we're not going to do the trig here, we're just going to subtract, right? So if I want the measure of angle C, that's going to equal what minus what? How do I find the measure of angle C with subtraction, guys? 90 minus the measure of angle B, right? But you never, ever, 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 ever type a decimal back in that you found on your calculator. Ever. Okay, I am not typing that decimal in. I'm also not storing it. I could store it in x and then just do 90 minus x. That works. And there's nothing wrong with that. But what I want to do is 90 minus that number. So I'm going to do 90 minus, but I want to subtract that. And again, I am not typing in the decimal. Okay, I want the answer. So I'm going to hit my second key. You see the little negative sign right above it? It says A and S. That uses the last answer you have. So 90 minus that answer, bam, there you go. Bam, there you go. Okay? And that's what you get is the 58 point, whatever that is. So the measure of angle C, stop whistling, equals what? 58.052. Okay. There you go. Okay? We good? Any questions? All right. Now, could we have stored it? Yes. I know I kind of zipped through that yesterday, and I think I'm gonna want to talk back through that example a little bit once we're done with this. But we all good at this point? Now, I need to still find any questions? Yes. Because I had to pick an angle, and somebody said B. Because you got to find them both. It doesn't matter. We could have started with angle C. But we have to find them both. So it doesn't matter which one you start with. In this case, you just have to do them both. We could have done this one first and done the trig for angle C and then just subtracted. We could have done the trig for both of them. That's fine too. Which is really the safer way to do in case we messed up on something, but you know, it is what it is. Okay, we good? All right. So now I need to find this missing side. I'm going to call this X so that I have something to call it. And then I'm going to do what to get my exact answer? Pythagorean theorem, okay? So go ahead and get started on Pythagorean theorem with that, and I'm going to go check roll. Okay, so I have x squared plus 12 square root of 2 squared equals 20 squared, all right? So what is 12 square root of 2 squared? How many of you use your calculator to square that? Okay, go ahead and use your calculator. Square 12 square root of 2 squared. It's 288. If you type it into your calculator, like most of you will type it into your calculator, it's going to give you 24, and you are wrong. Don't touch the calculator, all right? Because you need to understand the concept anyway, and then you think because the calculator gives you a number, it's like gospel. Oh, well, that's what the calculator said. It has to be right. Yeah, no. Again, it's only as accurate as and intelligent as the person pushing the buttons. So this is really what it needs to look like even when it's written. Just putting a little squared there, all I'm really saying when I write it is to square the square root of 2. This is how it should be written. That's how it should be in your calculator as well, but the calculator opens those parentheses there. So I square the 12, which is 144, and then I square that, I get 2, so it is 288. So good job, guys. Equals what? 400. Okay, so x squared equals what? 112. Okay, so x equals the square root of 112, right?
Teachers and students, please find this promotion. Teachers, if you have any students that are participating in the 8th grade visits today, please dismiss them to the auditorium at this time. Thank you.
Okay. So if I can get down to that point right there, then what's my answer for x? Four square root of 7. And that is the length of AC. Is that what it's called? Normal AC. Okay. Okay. There you go. All right. Any questions at this point? We good? Oh, who else is leaving? You grab that crystal for me. All right. So a soccer ball is 8 foot tall. You kick a ball from 10 feet away that hits the crossbar at the top of the goal. At what angle is the ball kicked? All right. I'm going to give you a second. I want you to draw the picture. Okay, so raise your hand if you have no clue about soccer. Really? I'm like the only one. I've never watched a soccer game in my entire life. Okay. Oh, well, it's okay. I mean, you don't have to watch one. I mean, if you understand. So how many of you does anybody not know what a soccer goal even looks like? Okay, wow. That's like a first. I always have somebody that's like, I don't really know. Okay, but I could make this in anything. I could make this a bocce ball goal. Do you know what bocce ball is? They don't have goals, but it's the only thing I can think of. A thingamablob goal. Do you know what that looks like? You don't, right? So my point here is this, is that it doesn't matter if you know what it looks like or not, because you don't have to actually draw a beautiful goal, right? All that really matters is that you understand that you have something that has a height to it, right? We don't have to draw the extra stuff on the picture. So the goal, whatever it is 8 feet tall, right? You kick a ball from 10 feet away. So you're 10 feet away. Here's you. You're about to kick this ball, okay? Oh, 2 arms. And it hits the crossbar at the top of the goal. Even if you don't know what the crossbar is or you don't know where it is, it tells you it's at the top. So it hits up here. Bam. At what angle was the ball kicked? Right? So I have people that have trouble finishing this and not knowing what, if you're going to kick the ball, okay, you're not like flying up here and going to kick it, right? You're down here and you're going to kick the ball. Sure, I mean, it could be in the air, but it just doesn't really say that, but it is what it is, right? So you're going to kick it from here. It hits here, so bam, there you go. Okay? You kick it from 10 feet away. Where does the 10 feet go? At the bottom, right here. Okay? This goal, the goal is, even if the goal is not perpendicular, because they lean a little bit, right? But the height of anything, how tall something is always a perpendicular measurement. Does that make sense to you? So how tall it is perpendicular, even if the goal itself isn't. It says at what angle was the ball kicked? So am I looking for the angle up here or the angle down here? Down there, right? Before you ask a question like, well, if it says to look for this, am I looking for the hypotenuse or what am I looking for? Think through what makes sense. Would anything else possibly make sense because that's what you have to do when you're at home and you can't ask anybody, right? Really think through if anything else makes sense. All right, so now I'm looking for this angle. So I can label this. This is the opposite. This is the hypotenuse. This is adjacent, right? And which trig ratio am I using? Tangent. So the tangent of what? X is equal to 8 over 10. So X equals the tangent inverse of 8 over 10. Okay? So you can find that inverse. What do you get? 6, what? 0. And so I can't leave it as X. Did anybody ask me to solve for X? No. Okay, they asked what angle the ball was kicked. So it's fine that I have X because I used that in there, but I need to label my answer correctly. This is the angle ball was kicked. And I'm done. Anytime you're looking for, so her question was, how do you know when to use the inverse? Anytime you're looking for an angle. If you set this up based on what you know, you don't have to think about it before you set it up. You always take the sine, cosine, or tangent of the angle. If it's a number, you put a number. If it's a variable, you put a variable. And then you put the ratio of the sides. If they're numbers, they're numbers. If they're variables, they're variables. And you set it up. Once you have it set up, if the variable's over here, you solve it like we did yesterday. If the variable's here and you're using an angle, you're looking for an angle, then you use the inverse. Does that make sense to you? Okay, we're good on that? That's a very good question. Anything else? All right, so we have a couple minutes. I want you to look at your notes from yesterday. I'm not even sure that I can actually